All right, this is problem 1 on 411. If you haven't done problem 1 on 411, stop, go ahead and do it, and then come back here and we'll show you how to do the problem. You can check your answer. All right, so doing this problem, I would subtract cosine x from both sides. Do good algebra, right? So I'm doing good algebra. I got 0 equals 2 cosine x minus 2. Now I need to solve it. I move the negative 2 to the other side. I get 2 cosine x. Divided by 2, I get negative 1 equals cosine x. And then it says solve for principal values. Principal values for cosine are going to be the top quadrant, right? So it's from here to here. Where does cosine give me negative 1? Cosine gives me negative 1 right here at 180 degrees. So x equals 180 degrees, and I am done. Not so bad, right? All right, I'm going to do problem number 3 in just a moment. If you haven't had a chance to do problem number 2 and problem number 3, sorry, if you haven't had a chance to do problem number 3, please do problem number 3, and then I'll catch back up to you in a moment. Pausing. No. Okay, now I'm starting problem number 3. Problem number 3. So here I'm going to the same situation. I look at it, try to do good algebra. There's nothing good to do. I can't do anything with secant and tangent as long as there's secants and tangents, which leads to the conclusion that I must switch them into sine and cosine. So I would do something like this. 1 over cosine squared x plus sine x over cosine x minus 1 equals 0. Now I'm back to doing good algebra. I've got fractions, so I'm going to need to add those fractions up, right? So I'll start adding fractions. I need a common denominator. I would notice, oops, where's my pen? Okay, so I would notice that I've got a cosine and a cosine squared here, right? So I just need to multiply top and bottom of this one by cosine. So I'm going to go 1 over cosine squared x plus sine x cosine x over cosine squared x minus, now I'm going to make this last one equal to a cosine squared. So I'm going to go cosine squared x over cosine squared x equals 0. So I get a little random line here. Let's see if I can fix that for you. All right. So now I'm looking at this and I'm trying to figure out how to get this problem done. Adding fractions, right? That's what I should do. So I'm going to go ahead and add the fractions. I got 1 minus sine x cosine x minus cosine squared x over cosine squared x equals 0. Now I have a couple options here. One of the options is to look at it and go, well, I don't want that cosine squared on the bottom, so multiply both sides by cosine squared. The other one would be attempt to get rid of that cosine squared that's sitting here. But I'm going to multiply both sides by cosine squared because I think it's logically most of you would do. And so I get 1 minus sine x cosine x minus cosine squared x equals 0. It's terrible writing. All right. So now I got to do some good algebra. How the heck do I do good algebra with this? Well, I might notice that I have 1 minus cosine squared, right? So there's no good algebra. Nothing else I can do, so I'm in desperate land. So 1 minus cosine squared, I can change that to a sine squared, can I not? Or I can attempt to factor this. Now I don't think you can factor this, so let's go ahead and go for 1 minus cosine squared is sine squared. So I come over here and go sine squared. Terrible writing, sorry. Sine squared x minus sine x cosine x. Remember that's that 1 minus sine squared, 1 minus cosine squared is sine squared, so that's where I got that from. Now I can factor it because I have a common term. I have a sine in both of these, right? So I'm going to pull out a sine. Sine x, and that's sine x minus cosine x equals 0. So now I'd go, all right, so set each of the factors equals 0. That's what we did a long time ago. Now we're doing with tangent functions, sine, the trig functions. Sine x minus cosine x equals 0. Equals 0. So where does sine x equal 0? Sine x equals 0. Well, I'm looking between 0 and 360, so sine x would equal 0 at 0, at 180 degrees, and at, it doesn't include 360, so I stop it there. Need little degrees on the top there. Now, that would answer the question of where does sine equal, right? But I got sine x minus cosine x. Now, I showed you this trick a little while back. It was just the beginning, but we'll give it a whack anyway. So I got sine x equals cosine x. And the reason why I'm doing this is I'm going to try to get whatever sine x and cosine x in the same expression. I'm going to try to get it so it's sine x over cosine x so I can turn it into tangent, right? So I divide sine x by cosine x and I get tangent x equals 0. Well, that's terrible. I should have done that in 2 steps. All right, eraser time. All right. So now I'm going to go sine x, divide both sides by cosine x, and I get sine x over cosine x equals 1. That's tangent x equals 1. Where does tangent give me 1? Tangent gives me 1 at x equals 45 degrees. And that's a repeat every 180 degrees, but every 180 degrees, so that would give me 1 in the 3rd quadrant at 225. So my answers would be x equals 0 degrees, 180 degrees, 45 degrees, and 225 degrees. Now, any questions? Oh, well, any questions? I can't ask any questions because you're not here. So there you are. That's my answers. Okay, so again, do good algebra. There's a desperate step in the middle here. Set it equal to 0. Factors, set each of the factors equal to 0. Solve for each half. Okay, and get your answers. Since it says solve between 0 and 360, I'm limited to those answers, so that's what I do. All right, I'm about to number 5 on 411. If you haven't done 5 on 411, you're cheating. Go back, do the problem, try it out, at least get stuck so I can help you with this problem. All right, for the rest of you, here we go. I've got 4 sine squared minus 4 sine x, or 4 sine squared x, minus 4 sine x plus 1 equals 0. So first thing is do good algebra. Now, that might not seem like something you can do, but guess what? You can. How can I do good algebra? Here, I can look at this and say, hey, this is just a normal quadratic. If this was written as 4x squared minus 4x plus 1 equals 0, we could solve this. We would say factors of 4, that give me negative 4, that would be negative 2 and negative 2. And then I could factor this as x equals 0. These two have to give me 4, so I have to have a 2 and a 2. 2 times what gives me negative 2? This negative 2 here. And 2 times what gives me negative 2, and those are my 2 factors, right? We're going to do the exact same thing over here, except we're going to do with signs. We're going to say factors of 4. That give me negative 4. That's negative 2 and negative 2. Now I give myself parentheses. Boop, 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 equals 0. Except with the x, I'm going to write sine x because I'm actually factoring a sine x, aren't I? So sine x, I'm going to put my 2 here because my 2 and 2 have to give me 4. 2 times what gives me negative 2? That would be negative 1. 2 times what gives me negative 2? Negative 1, right? And so now I'm going to go ahead and go 2x sine x minus 1 equals 0. And 2, oh, wait, that's not, what's 2x? What did I do there? That's not good. Let me fix that. Just 2 sine x, right? And then 2 sine x minus 1 equals 0. All right, these are the same thing, so I'm not going to solve it twice. I'm going to go 2 sine x equals 0, or equals 1. Oops, 1 there. And then that means sine x has to equal 1/2. All right, where does sine x give me 1/2? I look over there and it says between 0 and 2 pi is the answer, says I have to be in. So I've got to get all the ones between 0 and 2 pi. So a couple ways you could do that. You could remember how to do radians, or you could go degrees. X equals 30 degrees. Where else would it be? It has to be 2 places, right? So since it's positive, it's going to be first and second quadrant for sine, because all, sad, tigers, whatever. So sad is over here. This is 30 degrees, which means this has to be 150 degrees, right? All right. But we can't write it like that because it says do it in radians. So I'm going to go 30 degrees, where 360 degrees is equal to 2 pi. So that gives me 60 pi over 360. I recognize I can factor out a 10. 6 pi over 36. I recognize I can factor out a 6. And so that's pi over 6. And that's one of my answers. And then I do 150 degrees. Going to do the same thing. I've got 2 pi over 360. Sorry about that, 360, terrible. Okay, and that's going to give me 300 pi over 360. So I recognize that I can get rid of a 0. That's 30 pi over 36. There we go. And that's going to be equal to 5 pi over 6. And so my answer would be x equals pi over 6 and 5 pi over 6. Done. Going to do 7 in just a moment. All right, this is problem number 7. If you haven't done it yet, you have to go back and do it because it's going to be, this is one of the problems you have to recognize. So you have to try it first. If you fail at it, come back and we'll take a whack at it. So you can kind of learn how this works. So first thing I recognize, I've got x's and I got 2 x's. There's only one thing I do with that. It's automatic, immediate, and total. We're going to immediately go to identity. So I look on the identity page and I see that it's 3 cosine squared x minus sine squared x is what the double angle identity for cosine 2x is, parentheses around it, minus 5 cosine x equals 1. So far, so good. Then I would go, that's just 3 cosine squared x minus, everything else is in terms of cosine. Every last bit of this is in terms of cosine, except for this one sine squared. So, since I got no great algebra to do, I'm going to go ahead and kill the one sine squared x. The way I do that, of course, I'm going to write 3 cosine squared x minus 3 parentheses 1 minus cosine squared x, right? Because that's the identity for sine squared. That goes like that, right? Minus 5 cosine x equals 1. So then I'm going to go 3 cosine squared x minus 3 plus cosine squared x minus 5 cosine x equals 1. Combine like terms, I got 4 cosine squared x minus 5 cosine x minus 4 equals 0. Factors of 16 that give me 5, or negative 16 that give me 5. I've got what? I've got 8 and 2 doesn't work. I've got 4 and 4. This isn't working out well. Did everything right? Uh-oh. Pausing. So it helps to distribute the 3 through. Right there, I should have put a 3, right? All right, so that gives me 6 instead over here. That's a 6. Then that's factors of negative 24 that give me 8, and that's 8 and negative 3, or actually negative 8 and positive 3, right? So I'm going to go ahead and do my parentheses. I've got 3 cosine x. I'm rushing it. All right, and I've got, to make the 6, I'm going to have a 2 cosine x. In parentheses equals 3 times what gives me 3, that's plus 1. 2 times what gives me negative 8, that's negative 4, right? So then I'm going to set each of these equal to 0. I am out of time, so I'll pick this up on the next video. Boop.